Good morning, Pavan. Good morning. So, shall we start? Well, in the previous session, okay, in the previous session, we discussed about the various different techniques that is related to how we are supposed to get into machine learning, artificial intelligence, and data science algorithms. So yesterday we discussed about like KNN and other algorithms, how to implement. So I believe now I just want to ask like, are you using any IDE or you are working on online? Is it Colab, Jupyter, or you're using VS Code? Which IDE you are using? Pavan, you are on Colab. Okay, good. What about others? Are you using Colab or Jupyter or any other? Acha, Suvida, you are on VS Code. Very good. Ashish Colab. Perfect. Good. So, I think now you are quite comfortable that how to proceed with this Colab and all. And anybody is on Docker? Anybody is working on Docker and they anybody deployed this data science image on Docker? No, not at all. Okay, good, fine. See, this is completely is your practice part, like how you can work out. Colab is good to go, no doubt in it. Or VS Code is again good because for VS Code you can go for a native applications as well. That is related to the operating system. So anything which is related to the operating system, you can proceed with the VS Code, or either you can try with the Jupyter on Docker. So that is basically supporting your hardware architecture, right? But if you're on Colab, then machine learning, artificial intelligence won't be an issue. Data science won't be an issue, right? But anytime in case we are supposed to work, so I'm just giving you the benefits and the limitations also, right? So if you talk about limitations in that case, especially with the Colab, you cannot use some native applications like you have your operating system related some platform where you want to perform some task. So because it's online, it's cloud, so you do not have the rights to access directly over there. So that could be some hassles being identified. Otherwise, for machine learning, AI, data science, data analytics, I think Colab is good to go, or VS Code is also good, right? And make sure, obviously, your all the codes are there in your Google Drive, so you can save your data in Google Drive, right? And you can access things from there as well. So you have a copy which is cloud based services for the research purpose, so everybody can go with these kind of platforms. And my another concern is how many of you really complete your W3 schools part, that is related to machine learning algorithms which were mentioned over there. So did you complete that or still going on? Is that still going on, or did you complete your W3 schools part for machine learning and all? Are you working means on those algorithms? Acha, so with the working, good. That's good. Means see, generally, just want to say, like, if you are using W3 schools for Python, in that case, you will find a lot of details, like some basic algorithms are already there. So if you just complete at least file handling, because file handling is important, so you must try to complete the file handling part of it, and try to complete your various Python modules. That is at least the three modules which were mentioned, that is NumPy, Pandas, and SkyPy. Three modules which are there. I'll share my screen, I think would be better. So I think you can see this screen. We have various different topics in W3 schools Python, and there you have some modules like NumPy, Pandas, and SkyPy. Try to complete these libraries. And another very important for analytical part, that is Matplotlib, to get all the plots, what is the difference, and why we use like scatter plot, or why we use a histogram, pie chart, or in case if you have seen that confusion matrix. So we did that one of the plot over there. So there are various different plots, so better you should complete these algorithms. Then I think I prefer, then you go with this particular part, right? So machine learning, where you can go and figure out a lot of algorithms, common algorithms. There you have a confusion matrix, also decision tree, training and testing. I think that concept must be now clear to all. And question generally is related to like what is the difference in regression, what are the different various types of regression, like a linear regression, multilinear regression, polynomial regression, right? So these are the types of regressions where you have to handle multiple variables and work on that, where you have dependent independent variables and correlations of that, and you can identify. The other important part is your logistic regressions, right? And again, confusion matrix, k-mean algorithm is important. KNN, I think yesterday we did a KNN also. So please work out on various different algorithms, because these algorithms will certainly going to help you in your examinations, and you need to answer the things like how it works. So theoretically, I believe you must have completed, but how to implement practically, in this session we are supposed to do certain practicals, right? So that is why I told you, please start working on these various practicals. That would be really helpful for all of you. Uh, okay. Yeah. So I think in the last session we were discussing about, like, see, this is your KNN, and this is related to your machine learning algorithms. This is KNN. Can you see KNN?
No, sir.
Sure. Okay, give me a minute. Is it visible now?
Yes, sir.
A book actually, MCSL 228, where we are supposed to do various machine learning sessions according to your book. Please go for it and check how to implement. So yesterday we tried to cover that part, that is KNN model. And apart from that, you also have to go like naive based algorithms for data classifications. This is all basically for classification, data classification, right? Classifications either in the terms of variables or in the case of classes. So we try to create certain class and find the value of k, and then we are trying to approach same way like we have a naive based algorithms and try to identify the distance between the particular points so that you can able to identify which one belongs to which particular class. So the way how you classify your data, it is related to classifications. Apart from that, then we have another concepts of decision tree matrix and logistic regression. Both are also used for the classification, but that is more hierarchical based, like as decision tree is mentioned. So how to implement that decision tree, and what is the concepts of logistic regression. At least you should do all these algorithms practically and then try to implement in your codes. For that, I have already gave you the way how you can proceed with these algorithms, right? And I think you can check. Uh, we have a concepts of decision tree. So even you can go with the decision tree, how the decision tree works. So there you have some options like uh, what is the concept of decision tree altogether. Just give me a minute. Yeah, I think now you can see the decision tree. What is this decision tree all about? And if the condition is true or false based on certain values, you can define, you can make multiple decisions and try to create a criteria. So basically, it is relative like you have some data set in case if you have a collection of data set, and whenever you have a collection of data set, how can you identify that which type of decision is correct for us? So let us suppose we have a lot of data, and based on a lot of data we need to decide whether if the condition is true, or based on multiple conditions or nested conditions, right? We need to identify the probability, and based on their probability, the higher level of the probability means the higher decision making model. So how can you decide, like today you are supposed to go with MCA in this AI, or any other topic, or what you decide, like whether we are supposed to go with let's say this is again the question, and at the beginning I just ask you, take a decision that which is good for you, whether you should go with the VS Code, you should go with the Colab, or you should go with your Jupyter offline by using Docker, or why not the third party resources like W3 Schools, or Geek for Geek, or Kaggle, where you can get the code and you can execute the code there and then. So the concept is, let's say, uh, let us say define some task. I want to do this task, and for that, who use what, right? Suppose I have some that kind of data set, and let's say we are right now, I think good strength, we are right now total 23 people are there online at this time. And let's say all 23 will give a vote and will create an Excel sheet, and an Excel sheet will define like who use what for which purpose. So for machine learning, what do you use? Let's say I'll make a one Excel sheet for machine learning. I use Docker, or somebody will say I use VS Code, I'll use Colab, or I'll use like Kaggle, or we have multiple choices, right? Based on like what type of criteria or the programs you are performing. So we'll get the list of the suggestions, or you will get some proper survey kind of, like on that basis now, of if any person is a new person who want to take a decision, right? So what is the level of accuracy, and what is the higher probability, that how you decide. Now for you, you have 4 5 6 good options, and out of that, which option is better for you? How can you decide which one is better for you, right? So that decision, how you can take that decision. So decisions are like in 11th and 12th you stuck, even after 12th you stuck what to do. So that level of decision, how people take decisions. So can we create an algorithm, and we can implement some algorithm for decision tree, right? So there you will find a one algorithm called decision tree, where you can define all the constraints, conditions, and those conditions which are again hierarchical conditions. Based on those decisions, we need to generate some results. Okay, we need to identify what is best or what is good for us. So you can create that level of decision tree, and based on those decisions, what would be an output, what is the result, and how can we decide which algorithm is better for us. So that is the basically a purpose of decision tree. And in this decision tree, you are trying to create your tree structure of the flow chart, and with your constraints. And let's say we have some content, and if you just go through with the content, like in this example of say this W3 schools, we will show you how to make a decision tree in a flowchart, and can help you to make a decision based on previous experiences. A person will try to decide if she should go to a comedy show or not. Now, let's say the question is like today, some multiple movies or some comedy shows, and there are various other entertainment packages are available, right? Either you go to the comedy show, stand up comedy, or you want to go to some that poetry recitation sort of, or you want to watch a movie, or you want to go to any mall, or what. let's say we have some different choices, and out of that, which one is better, depending upon now your age, your level of experience, and some ranking given to it. According to that, which country is better to go, and really you go that for that particular part or not. So one of the person whose age is, let's say, 36, with 10 years of experience, carrying some rank, right, and the nationality is of UK, that person never go for comedy show. So whether that person goes for comedy show or not, so that person said, no, I would not rather prefer to go with the comedy show. Same way, you got some other citizens of various countries. Let's say you have of age of 42, 12-year experience, even they have less rank, working rank. Okay, but that person is a US citizen. That person also said, no, I don't want to go. Same way, there are various other factors being identified, and accordingly, you got some yes, no, and all for various countries. Suppose this is our data set given in this particular part. Okay. Now, on that basis, what we are supposed to do, let us try to create a decision tree. So for that, first your job is to collect that CSV file using pandas and take it in your data set. So you got a data over there. You can run the example parallelly, and you can see we just ran this code. So we import pandas, we call this data set. There you got a data set. This is what the data is all about. Okay. And if we use this Python code, then you got an output. Like there we identified our data set. Right now, if it is okay, it's good to go. Then to make a decision tree, all the data has to be in the numerical form. So this is a practice which you need to learn, that we have to go for a mapping. That is a data transformation, that we cannot access everything in the form of letters or any string. So what is the best practice? The best practice is keep your data always in some numerical form. So if your data is in the numerical form, so how to do this? Let us try to create a mapping method. We use a one map method in this case. And if it is UK, then convert that value into 0. If it is US, make it 1. If it is N for anything, you can take, say, Nagaland, or you can say any New York or New Jersey or whatever, right? So we have some options. Okay, so Nigeria, whatever. So let's say it is 2. Okay, so you can define some values like this. And in accordingly, if the nationality, so DF nationality, you're fetching this column. If the nationality mapped with the D column, so mapped with the D column, if it is written UK, then automatically value goes to 0. Right. And now accordingly, you got a value. So you got a some D. So first you did this part. First you complete this part, and accordingly we have an answer like go or no, yes or no, yes or no. So that data is also there at the in the column of go. You have a message called yes, no, yes, no. So only the part is age is in numeric, experience in numeric, range in numeric, rank in numeric, only nationality and go. These two columns are not in numeric. So we have to map it. We have to do a transformation of this data, right? So transform that data, and let's say if the value, let's say 1 is for yes, and 0 for no. Let's say we'll convert this part by using a mapping. So simply you can map your data and convert your data. And now if you run the same code, the moment you will run this code, and now your data being transformed into this particular part. So earlier my data was in this way. It is like in UK, US, or some in a string format. So this is a concept called as data transformation. We did a data transformation into a some mapping model. We use a map method, and we correlate and convert that data into some numerical form. Hope this concept is clear to all. Right. And once this mapping is done, afterwards, now we want a feature to be get extracted. We have to define some features, right, where we are supposed to identify features on x-axis and y-axis, so that all the feature columns, because these all are the the independent variables, and on these independent variables there is a one dependent variable like y column is go. So the person depends on like the decision is whether that person go yes or no, right? So person will go or not, yes or no, but that person based on what? So this is that go is a dependent variable, and these four are independent variables. And these four independent variables like age, experience, rank, and nationality. So with the combination of these independent multiple attributes, based on that we want to identify the dependent value. So let us that is why we kept everything into a x and y columns in the format, like say x is to be a featured of df. So we fetch df. Okay, df, from that df we already have a data set. We fetch the features of these only four columns into x, and then the fifth column, that was a go, we kept in y. So if you print these values, now you print these values, you will find only the first four values are there: age, experience, rank, and nationality is there. But afterwards, that go fifth one, the go value is completely different with zeros and ones. So we segregated that data, right, into two different collections, that is x and y. So good example. And afterwards, now let us try to create and display the decision tree. Can we able to design the decision tree on that basis? So how to perform? You import your pandas. In this case we are using a tree class from sklearn. So sklearn dot tree, and again one more nested that is a subclass of that, you can say, or we are importing the decision tree classifier methods, because from there we create an object. Okay, and then we have a matplotlib. So we are going to plotting that data. So finally your content is in this particular format. We fetch the data, we transform the data. Okay, this is the way how we transform the data. We split the data into features and independent and dependent variables. This is how it works. And finally, your data is in the decision tree classifier, and we try to fit that data into the machine learning model. So D tree is an object where we are trying to fit method from x and y coordinate. And on that basis, we got a D tree. And for that particular D tree, now we want to create a D tree with the feature names is equals to that is features. So first four variables. So as we have four good variables, on all these four variables, we are supposed to create a tree. So this is how you will get a proper tree structure, and you can find how things works. Sometimes, because they are supposed to manage their memory, they add few lines. ये आप शायद देखोगे, क्योंकि कोड में तो ये lines नहीं थे. And even afterwards you will find these kind of lines, because we are on the cloud and we are not using, it's all free services. So they display your data set, and finally after showing your data set they flush the memory, right? So for high performance, sometimes few extra code may be identified in your complete content. So you need not to worry, you just take a simple content and execute your content in your applications, and you will find how we get these values. So you got a rank. If rank is less than equals to 6.5, so we find a one Guinea value, total samples, and the values out of it. So there are 6 samples where the rank is less than 6.5. Okay, how many out of 7? There are 6 values where the rank is less than or equals to 6.5. So accordingly, they'll find the value of Guinea, and total number of sample is 13. So out of 13, 6 comma 7. So 6 comma 7 is like, you can see on the top what is this all about. So they mention things like this, right? Rank and also this is what the purpose is, to identify, and you got a tree on that basis. Understood? This is how it works. So you can check like out of 23 data set or whatever the size of that data set. Okay, I think not 23, it is just 10 or 11. I think 13, yes, from 0 till 12 we got 13 records. So out of 13 records, what is the size for true or for false? Okay, so if it is true, so this is what the value goes for the true. The left side is for your true and right side is, let's say, for false. If the condition is true, then in that case, the value 6 are true and 7 are false. So that is the first condition. Let's say rank is less than equals to 6.5. So if we calculate like this, the rank is less than equals to 6.5. In that case, how many values are there? You can correlate and find out where is rank. There you have a rank. Now check 6.5. Less than 6.5. So that is 1, that is 2, 3, then this is 4, 4, 4, 4, 4, 5, 5, 1, this is 1, this is 2, 3, 4, 5. So there are basically ranks less than this. Must be 5. Somehow it is written 6 into 7. Some value need to check what is it somewhere. Or equals to 6.5. Do we have anything called 6.5? So basically, these are the values, like how it works actually. So you got a total value upon which are true and what is false. Now, if it is true, let's go to this particular part, right? And if it is true, so total, yes, total samples are 5. Okay, there are total samples which are 5. That is what I was looking for, where the Guinea value is 0. Okay, or out of 13 samples, these are the values being segregated. Sample total is 5, and out of that, like if will compare it with nationality. Okay, so if this is okay, we got a true value and we got a result out of it. So 0 false and 5 true values on it, right? And if we'll now compare, now if the rank is false, if this is not the condition, then what about nationality? So in case of nationality, if it is a value, so we have to identify some threshold, and based on that, we can segregate the data. So that is equals to like 0.5 and then Guinea value and then sample. Total samples are 8, where your nationality. There you have nationality, and value is less than equals to 0.5. 0.5, nationality 0.5, less than. So 1, 2, 3, 4, and 5. So we got 5 values for nationality. So you can say we got a sample values. So total 8 values being considered. Okay. Okay, give me a minute. 1, 2, 3, 4, 5, 6. 6. 1, 2, 3, 4, 5, and this is 6. Okay, and on it we are comparing with data set. So total sample, condition true or false, rank. Somehow need to check where how that they prepared this graph, because if it is true, we'll go to the positive in this way. This is true side. I think there you have an explanation how it works. So whether it is true, it goes to the left hand side, and for right side this is false. And afterward they are comparing with the nationality. So you got a range, and out of 8, 1 comma 7 value. So total 8 values being identified, and because five were already being taken. Okay, five has already been, that is a condition which is already true. So we only got a seven, means 0 to 7. So that is total eight samples. So 8 plus 5, that is, you can say 13 samples. And out of 13 samples, the 5 was already true. So once it is already true, what is left? That is 8 sample. And out of 8, again, the condition once we are trying to identify, so we got 1 comma 7 value. So 1 goes to the true side. This is true side, where out of that 4 values, it is saying 4, 1, 1, 2, 3, 4, and this is 5. So minus 1, I don't know why it is always taking with what minus 1. Although 6, same way 5. So this is how you it is working, and it is showing you the graph like this. So this is 1 comma 7. Okay, and total 8 values, and that is to be separated 1 comma 7. In this condition, how many? So 6, that is what like the value. So 4 samples are true, and that is the Guinea value is this, and rest all which is not there. So we'll get into the case of age, where age is less than equals to this value, and then you got a Guinea value, sample value, and this value out of it. Same way means then they compare with the, if things goes well, only one value. So what are these values? You got a Guinea value and sample total over there. But if it is not, then it is to be compared with an experience, and on that basis you got the result. So this is a kind of a decision tree making model, right? What is that decision tree? So I think you just go through how it works, and I think in the theory also you must have gone through how to process this decision model, and you will get the results on that basis. So please try and work out, and I think you will find a good solution, and you can make and get the output like this. Everybody just try this code and check how thing works, right? So please just implement this practically. Basically, the moment you find this Guinea value, it is like the level of impurity. If you just go through that, what is the level of impurity, and that is to be mathematically calculated, right? Where it is to be identified, like where you can find some the number of classes in the sample. So how it was being classified, number of classes, and the proportion to each probability. What is the best probability out of it, right? So the probability model is there, and for each class in that particular sample. That is why like you find some impurity level. into it, and this is the way how you can calculate the impurity. So that is good to go. At least try. This is the best practice, right? So just try this code quickly. Everybody just try this code. You got a link. In machine learning, we have an option called decision tree. Just quickly go through with this code. Yeah, please, everybody just go through with this code, and then we'll start with some other algorithm. Quickly complete this code. Already it is mentioned in your course that how session 12 that is related to your decision tree and your logistic regression. So we'll go with then next with the logistic regression, right? So everybody just try and implement. Further, we have to go through with this SVM, again very very important algorithm called SVM. And then we have multiple regressions, support vector, data set of your choice, implement support vector. uh, for data classification, choose your data set of your choice. For regression, okay. So we are supposed to do SVM for data classification and support vector regression. on data set. So there we have multiple options. So we'll do one by one, but please quickly go for this decision tree part, right? Regression. I think it's better first you complete your linear regressions and other regressions and then come to the logistic regression. So we can go with the concepts of regression, although there are various different process. Even you can go directly, but you need to understand how this logistic regression works. So now what is the purpose of logistic regression? Basically, it is again used for the classification part, right? So it does this by predicting the categorical outcomes. Okay, unlike linear regressions that predicts the continuous outcome. So there is a difference in logistic that is related to the categorical outcome, and in case of linear regression, actually it is a continuous outcome. So what is linear regression, multilinear regression, and then we'll come to the logistic regression, right? That is why I told you to go through with this channel. So what is linear regression? Regression means what? We are trying to identify the relationships between these various variables. So one is independent variable and one is dependent variable, let us suppose. And that independent variable, we generally used to keep it, let's say, on x value and on x-axis, and we are the dependent value, which is based on that independent. So all the dependent values, let us keep it in y. So accordingly, we need to create the regression, and regression use the relationship between these data points to draw the line between them. So whatever the way, you have to design a one, draw a line on that, and it makes you more clear that on this line, the more the all the data points are relevant to the line, it is more near, and that is what, like, easily you can identify. You can predict that these all are somewhere relevant to that, and the values which are far off, right? So these are the outliers. This is called kind of a outliers. So what are the outlier points which actually try to make the changes in this decision line or regression lines, right? So we can able to identify that on that basis. So how does it work? That is, we'll need to find the Python values and all. So let's say we have a matplot. You prepare a one matplot, and this is independent variables, that is on x, and dependent variables on y. We'll place it on the scatter plot, and you'll get the point something like this, right? So this is your scatter plot, and all the points to be placed something like this. So it's a message called like dot show. So the moment you'll process, you'll find this value something like this. Now, once it is being done, and then we have to place the line. So for that, and further, we need to find the SkyPy library, and from there we'll find the stats. So in linear regression, under the stat class, we have a method called len regress. Len regress is the method, which is the inbuilt method of a SkyPy, one of the class called stat. So we got a stats dot len regress method. Okay, so we import it this and in this particular object sort of. So stats dot len regress, we have to pass the value x and y. So once you pass these value x and y, you will be able to identify multiple outcomes, like that is, one is slope value, interception value, R, P, and STD error, standard errors and all, right? So you got various multiple values which you can able to even display all these values in case if you want. So let's say we have one method, my function, And this function is nothing, it displays a slope multiplied by the x plus interception value. So we got a slope, multiply that slope with each x value. Okay, multiply that slope with each x value plus the interception value, whatever the interception value is there. Accordingly, you will get a return number, and that number is to be get plotted over some location on the plots. Okay, so accordingly, we got a list and map all the values. You know, map method, I have just explained you in the morning what is this map method. So on this map method, we'll pick x value one by one, we'll pick that value, place it in this function, and this function will return a output which is in the form of a list, and that list value goes to my model. This is how the way you got a model. Okay, this is the way how you got the model. So please try and understand first what is mapping. Mapping means overlapping to that, right? So you find a 1x value which goes to your my function. So this my function would perform, okay, with that specific x value, and that is what like being calculated slope multiplied by x plus interception. So this is what the output comes out of this methods, and that goes to the list, and you got a list of the values. Okay. Excuse me. So once you get the list of the values, you transfer that value into the my model, and under my model, then finally we'll go to the plot of scatter plot, place x and y coordinates, and then plot those values with the correspondence to x and my model. Okay, so whatever the list you identified, we keep those values for y positioning, right? This is for y positioning. So first you find a scatter plot x and y, and then plot PLT. PLT is the object which we selected. Then plot x, all for correspondence to each x coordinate, we find the value for y. And accordingly, you will get the line, and you can show these kind of things. So earlier, only the part which was different, that we already did a scatter plot on the basis of these value, we got a points, but the slope has not been designed on that basis. So that slope came across only once you try to plot it by using your model, and finally you get a proper line, right? This is the way how it works. So further, the explanation is there. You can go through the explanation step by step, and this is your basic model of linear regression, right? So how to implement this linear regression? So import this library. Again, after importing, we need a data set. So collect that data set, execute that method for the linear regression. So that is stats.linregress method is there. Pass your values of x and y, right? It generates these 5 different variables, that is slope, interception, R, P, and standard errors. There we want to create a function, we use a slope and interception values to be returned into the new value, and for that, and that is being generated for the y-axis model. That is basically for the y-axis corresponding values to the x, and that is what my function being designed. We create a model or one collection, and that collection to be simply placed on the plot for the correspondence of y-axis. So this is a very basic part, and on that basis you can find the results, and you will find a plot over there. Understood? This is the way how you will find the plot, right? And we mentioned this diagram, and then simply you show this message. So this is the way how you will get this linear regression part, right? So according to your book, you have to go through linear regression. You have a linear regression, and then we have a polynomial regression, both. So this is linear, and now I think we'll go with this polynomial regression also, and then we'll come back to the logistic regression. So shall I proceed to the next one? And afterwards, I think you can do all these regressions together. So even this is only for one variable, one independent variable, and one dependent variables. But now we'll go with the, let's say, multi-regression also. If you have multi-regression variables, then where we have a lot of multiple variables which are being allocated. Okay, in this way we have multiple variables. Okay, and in this multiple variables, we are supposed to do some task on it again. So import your pandas, read your data set, let's say it is in CSV file, and now out of it, because you have a multiple variables, now make a independent and dependent variables. So X variable, X is what I told you, that is an independent variable. So let's say there is I think the collection of some vehicle cars, and there's some model being mentioned. Accordingly, what is the volume of those cars and the weight of the car and how much CO2 being generated, and that is what, like, some data set. So on this particular data set, we are supposed to do various things. Let's say we'll come to this part and import the data set, use this CSV into a DF. Okay, and now we find some what independent variables. Let us take some two independent variables, because in linear we did only one independent and one dependent variable. But in multilinear regression, we are taking multiple uh, independent variables and one dependent variable. That means if there is a weight and the volume is this, if two variables are matching to each another, then the corresponding values of y, that is CO2, should be there. Okay, so this is the purpose how we are supposed to do, right? And now we are trying to go and import a linear model from sklearn. Earlier we did it from scipy or so, right? And there we have a start method, len regress method, right? And now we are supposed to do a proper linear regression model from sklearn. So in Python, I think you are quite comfortable, and you know that we have a various different algorithms, basically various different models or libraries. And in these libraries, we have those models. So the first one you did it with len regress method. And now what we are supposed to do, because we have to fit again, and we have a one more method called linear regression. So up to you, you want to go through with the sklearn or scipy, right? So there we create an object called regar, which is equals to linear underscore model is the class which you are calling, and the method is like linear regression. Fit a method, fit a method of x and y collection. So whatever the x and y which has already been defined, let us try to fit it with this linear regression method. Okay, this is the way how you fit your data. Now we have a regression object, REGR, regression object, and that is ready to predict the CO2. Now, if you give me the weight and volume, then what would be the, can we able to predict? So prediction, that is we can able to predict. If I'll give you a weight and volume, okay, weight and volume, what would be the CO2, expected CO2? So can we able to predict based on the existing data set? So this is the way how we are supposed to perform. And under this criteria, you can see uh, we have concepts of this predictions. You can find predict CO2 emission, right? Emission of the car. So in case if these are the values, say 2300 kg as a volume, and that is the weight, and the volume is 1300 centimeter cube. See, right? So that is the two values. First is weight and second is volume. Okay, so on that basis we are trying to predict the value. So how to predict and what would be an output? For that there is a code. So let's say you import your values, use your algorithm, pass your data set, identify your columns for independent variables which is to be placed in the x, dependent variable which is to be placed in the y, and afterwards we need to run the linear model dot regression method and create an object on that and fit your data set over there. Once you fit, everything is fine. Simply you just need to place it and it's all being done. You already mentioned these are my data set. And finally, we'll simply go for the prediction. In case my weight, and volume of any car is this, then what would be an expected predicted value? So you can get the calculated value, which is this one. So this is the way how you can handle multiple regression. So I hope now the concept is clear about linear regression and multiple regressions, right? So finally, afterwards, after doing all these things, let's come back to the another model of polynomial regression, because the purpose to complete the polynomial, you have a one more polynomial regression, and one more is left. That is your uh, we have to do logistic regression. So what is polynomial? Polynomial, polynomial graphs and all. So in that case, we are supposed to do the polynomial. This is what the polynomial graph, as I was talking about. So what is polynomial regression? Generally, in case of linear regression or multilinear regression, our slope is always in the form of line. So in the case of line, we found a lot of outliers which are really not matching those data points, which are not matching to that existing data set, right? This is the way how we have to identify. So every time in case of regression, we have only the slope. Okay, so it's a single line, straight line. But polynomial is like whatever the data set we have, we are targeting to create a polynomial. We'll try to create those, even the curved polynomial regression model. So my line is not straight line. Now it is in the curve point of view, to just to identify what the maximum relevancies of those points with the slope, right? So that slope, that line is in the tilted, or you can say with the with the basically that's a polynomial graph, right? It is goes into that particular format. So my line this time is not in the straight line. So we need to find the most relevant points, because sometimes we have a zigzag data, more out of the track data, which is unpatterned data. So if it is unpatterned data, can we able to identify how to identify what is the level of graph? So even share market is like unpredicted value, that is not always in the study format. It is not on the linear format. Generally, in that case, like that's why like in share market also we can apply like polynomial regression models. So find the relevancies of it. Okay. So how much it is relevant to that graph, or how much it is out of that graph. So that is the importance of this polynomial. So if you have a data point clearly will not fit in a line. So if it is not going to fit all the things into the line, then what is the best practice? The ideal regression algorithm called as polynomial regression. Okay. This is the way how we are supposed to do the polynomial regression. Okay. This is what the best practice which we used to do. Next, so the polynomial regression, like linear regression, and the relationship between the x and y variables, to find the best way to draw a line through these data points. These are all the common data points which we are targeting. So how it works? Let's see the Python finding a relationship between the data points of the polynomial regression. It shows you these methods instead of going through the mathematical formulas or so. So let's say we have records of 18 cars, okay, and passing through a certain toll booth. So if it is going through a toll booth and we want to register some values, what are these models and all that? Based on their values, we'll try to extract some information. Let's say trying to make it some hypothetical case. So we have a registered car speed which is already there, and the time of a day or hour being passing occurred. So at what time this cars, or at what time it is being passed on. So we have some y values, let's say x coordinate and y coordinate. So on x-axis it represents the hours of the day. So that is on the basis of hours 0 to 24. At what time which car being passed out, right? So we are going to place the x-axis represents the hours of the day, and y-axis it represents the speed. So y-axis will give you the speed. Now on which hour what would be the speed, that is unpredicted, generally unpredicted. But is there any pattern over there? So to identify that level of patterns, we use a polynomial regression for this particular data set. Okay, say at 1 means midnight, 1 a.m. At 1 a.m., the speed of the car is 100, and accordingly it varies, right? And you can find some values of that particular various time zone. So x-axis is your hours, and this is y-axis, you have a speed. So time is constant, so we kept a value as a independent variable in the y, which is in the x. So in the x, we used to keep an independent variable, that is your hours of the day, and the speed which varies, which is uh, a dependent variable, will try to manage to place it in the y. So place your scatter plot and show the plot. So you will get something randomly like this. Now we cannot create a line statement like this or that, because then a lot of outliers are there. So it means the data set is not fit for linear regression. That is why we are planning to go for a polynomial regression. Okay. And now on that basis, let's say we'll try to create some kind of a slope sort of, right? Or polynomial, basically a diagram. So for that, again, you import your numpy and plot. You have same data set. Now, before you get into it, let's say we convert that data into a model by using numpy.poly1d. So we are trying to convert that data set into the poly1d method under using numpy.polyfit, and under polyfit we are supposed to give some dimensions. Okay, x and y coordinates. Excuse me. Now, based on that, we create a model. We have my model, and under this model, let's say numpy dot line spaces, whatever the numpy and line spaces, the values comes across, you will find some values, and we need to give some gaps and spaces on that points. So just mention these part, and you got a my line, and simply on the plot give your my line values and place your model over there for y-axis. So my line is your x-axis, right? If this is your x-axis, that is also need to be calculated because it is not a constant now, right? And y is already dynamic, and now in this case x is also dynamic. So that is why in the previous session, that multi-regression, you must have seen your x was a constant and y was varying. That is why we got a slope where x was constant, but now x is also varying, it's dynamic, and y is also dynamic. So we need to calculate both. That is what, like for x, and that is for y. And finally we got x and y, and that model is to be placed within the on the plot to find a proper polynomial graph which are associated with the existing points or data points, right? So this is the way how you can process, you can make your positions, fit your data set, right? Starting from, let's say, the position from 1 till 22. So there you have a polynomial data fit values, and this is to draw the original scatter plot, right? And first to 22, that is your starting point, ending point of the line. So starting from 1, ending with 22, that is what, like somewhere it starts from 1, there you have 1. Okay, at this stage you have 1, and close to 22, there only you stop your point. So starting point, ending points, and the relational part for x-axis, that is what your data set is there. And then draw the scatter and place your data set and show the output. So this is your diagram. Clear? This is how you can get into it, and you can proceed with the model. So try to make these kind of things, and this is a polynomial part. Even you can find the r square value, r squared values out of it, which is nothing but the matrix which you want to find the best matrix pointing between x and y coordinates. So you will find a proper coordinate, and r squared value in case you want to identify. So there you have some prediction future values, what would be the value for any particular instance at, let's say, 5 p.m. what would be the speed. Now, can we able to predict, because 5 p.m. has not been mentioned in this list. So at any time like 5 p.m., right, what would be the speed if we want to calculate something like this? And or at any particular time, let's say car is passing at 1700 hours, right? So at 1700 hours, if it is passing, if on this model you pass some value, say in this case we don't have 17, you can see we have 16 and 18. We have the value for 16 and 18. So any missing value or any value on which you want to predict, let's say we don't have 23, we don't have 24 or something like that, right? So we have, let's say value 17 is missing. Now if 17 is missing and I want to predict what would be the value for 17, where the value of x could be a 17, so in that case the prediction comes across according to the data set. So we'll get some tentative prediction. And that speed could be almost 88.87%. And this is how being placed in the graph. Okay. This is how you will go and check your R square score. And let's say passing those values on R square, fit your values, everything is same. You got a model, right? And on this model, now we are passing the value 17 on this particular point, which is the value for X that could be considered as a speed, and simply display the speed. So on this model, it calculates the value and give you the exact point, which you can find the exact value, that is 88.87. So X already defined, that is 17. And for Y we want to predict, so we got a point that could be, this is the point R squared value to for the prediction of using any polynomial regression model. All right, so this is a good one, a good example which you can try for polynomial regression. Any doubt? Is there any doubt with anyone? Hope this concept is clear.
Uh, Sir, one question is there.
Yes, yes, please.
May I ask, sir?
Please, please.
Sir, when we are talking about linear regression, uh, 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 linear regression, we find that if R value is near around 1, then my regression is good. So similar fashion, sir, polynomial regression also we judge about R value.
Yes, we can judge that R value. Say there, that's what like the model is available. And that is why we are trying to correlate and we'll try to find this value. So for the prediction purpose, also will identify the nearest value is like 1. And even we can have some distance. The more distance you will find, the more gap. That is the error. Generally, that is the error being generated. So the more value which is near to the line, that is what like on the basis of that R, we can also correlate.
Yeah.
This is what,
Okay,
just
sir.
take a look about this data set now. Let's say we have a bad fit. Now if you go and check the bad fit, suppose we have a very much random data set and now you try to fit. So what is this? Can you arrange this part? No, you can't,
No,
right?
no.
It is a very bad fit data set.
Yeah, yeah,
Understood. That's what
yeah,
like and there is a
yeah.
R squared value. There is a concept of R squared value, and so that we can able to figure out like what is the relationship of these value, which is a bad data set. So point 000, this is your R squared, right? So that means it is very bad
Yeah.
relationship, and that is why how you are supposed to identify, right?
So means this R value works in all kind of regression. I
Yes, yes, yes,
means
yes.
linear, polynomial, multiple.
It
Yeah.
works
Okay,
over
sir. Okay, got it. Thank you. Thank you, sir. Thank you very much.
there. Right. So let's go to the next algorithm. Another one is your logistic regression. So let's go to the logistic one. Now, in this case, especially in this logistic one, you need to find like how the things process, and now just try and classify as used for the classification again, right? And classification, that is to find the prediction. Earlier regression being used for the prediction, but there is a one more algorithm called logistic regression which is used for classifications, and on that basis we'll go for a prediction of the categorical outputs. So there are two different ways in regression we use generally, right? On the data, or we used to categorize the data into a particular some outcome based data set. So it is unlike your linear regression that predicts the continuous outcome. तो देखो difference क्या है? In linear regression we got the continuous outcome. आप कोई भी next value which is missing value or the next value you can predict, and you can place that value and you can identify what would be the prediction, because that is in the continuous format. But in this case logistic regression, we are talking about the categorical data, right? So it is predicting the outcome based on the categorical data, that this value belongs to which particular category, right? So that is your logistic regression model. So in the simplest case, let's say we'll take a two outcomes, which is called as a binomial, and example for which is predicting if a tumor, so it's some related to some health disease. Let's say if a tumor is malignant or benign. Other cases have more than two outcomes to classify. In this case, it is called as multinomial. Okay, multinomial logistic regression, because we are taking multiple attributes on this card, and which would be going to predict the class of an iris flower between three different species. So we are going to calculate these values, and the logistic regression to predict the binomial variables. Now that means it has only two possible outcomes. So there are only two possible outcomes because binomial variables as a prediction. So there are only two outputs. The first, store the independent variables into X. That is what we always do. Dependent variables in always in Y. So there you have some data set. Let's say the tumor in centimeter. So some values are there in terms of centimeter, and you are trying to reshape these all values, right? And note that X has to be reshaped in a column from a row for a logistic regression function to work. And that means we have to reshape these values. So reshaping is important. We use a method called -1 to 1. That is your reshaping values of a tumor. According to that, we have some the tumor size, somewhere it is mentioned in some centimeters. Now let us represent whether or not the tumor is cancerous or not. So cancerous or not, that depends like on the various grounds, various other parametric part. But in this case, let's say we have a value for Y, which is dependent on completely these independent values of some centimeters of that size of the tumor. So some values are zeros and some are ones. Excuse me. So again, we'll use sklearn, linear model dot. Earlier we use a linear regression. Now we are using the method called logistic regression, right? Create an object. fit your value into X and Y, fit that value into this regression model. Okay. Now for prediction, predict if the tumor is cancerous where the size of any tumor is 3.46. So now 3.46, there is no such 3.46. So somewhere we got a new size, and if there is a some value, let us first of all again try to reshape, and because that is what to be get predicted. So what is the best practice? You will find the data, place your data, create a model of logistic regression, fit your data into that logistic regression, and now let's say we want to calculate, we want to predict. So for prediction, use a log r dot predict method, where your numerical value of the array that belongs to the value which you want to search, that is 3.46, and it is mandatory to reshape your data into -1 to 1. So it reshape it again, and on that basis we'll try to predict, and we'll go for prediction, and the output would comes belong over there. So whether it goes to 0 or it goes to 1, so output is it goes to 0, that means it is not cancerous, right? So in this way, it's a categorical. Output is in the categorical, the first categorical part or second categorical part. This is how you try to classify your data, you know, categorize your data in such a way that whenever you have a data set, and on that basis, which value belongs to which category, like red color, blue color, or some way like this, you can manage or you can understand. So accordingly, you can fit those values and get the result that it belongs to zeros or ones. So we got a zeros because it values somewhere near to the lower values, and almost all the lower values belongs to the value 0, and the higher value like this and above, that belongs to 1. However, you can see 3.69 is also somewhere cancerous. Obviously it depends on some other parameters might be, but at the same time 3.78 is again not cancerous. So you got some mixed form data, right? It is almost mixed categorical, but based on the higher probabilities, and the categorical part, it belongs to whatever the value being passed. Let's say we pass a 3.46. 3.46 is even less than this and this. Okay, where 2 is already not over there, and up to that limit it is not cancerous. It is not cancerous at this stage, so the higher probability goes to this particular group, and that is why the logistic regression predicts the value that this value belongs to the group where this size of the tumor is not cancerous. This is how it mentioned. This is a small example how you can find the logistic regression model, and further we can take it more in detail if you want. So you can find some coefficient of that, based on that which is to be categorical, and they'll compare from that coefficient value, so whether it falls to zeros or ones. So regression, the coefficient is the expected change in the log odds, right, of having the outcome per unit change in X. So if per unit, if the value changes in X, can we have a some coefficient value as per the changing of X, our logs odd comes over there, and it able to predict. So what is the centralized, or you can say threshold or coefficient values, we can able to figure out. So this does not have the most intuitive understanding, so let's use it for the creating something that makes more sense and odds. So again, using the same model, passing some again values for logistic part with some tumorous or not, right? Pass the same value, fit your so create a model, fit your data set into that model, and then let's say there is a simple variable called logs dot coefficient, coef underscore. You have to write like this, coefficients, right? Coef underscore. So this is one of the method internally, a variable kind of which returns a value, and you will get the value of odds. Now the odds equals to the expression, numerical expression will convert that value into the odds and print the value. So finally, you will get the threshold somewhere like 4.0. So 4.0, it means this is the threshold for all the collection of the data set, starting somewhere, I believe, from 0.14, which is, I believe, the lowest one, right? And the higher one, somewhere like a 5.88. Okay, 5.88. So in this particular part, we'll try to identify the coefficient value on the basis of data set and the relation of x and y coordinates. Accordingly, we got the coefficient, that is 4. Now, if the value belongs to less than or equals to 4, generally less than 4, so it is not tumorous, or if it is more than 4, then it is tumorous. So this is the way how I think this your logistic regression will be able to predict and place it your values into some categorical part. Understood how it works? What is the best practice? So you can find whether your value belongs to that part, which is the coefficient of it, and further you can take it some more probabilities of chances of any particular value. So there is a, you can even go and calculate the probabilities if required, right? So what is the, now in case you want the results in some probability, so let's say if I'll give you the value 3.78, what is the probability to be a cancerous? So to, you know, probability method, so what is the options out of total options? So total number of records upon that particular value which belongs to a particular record, so that might be a cancerous is like 61% or 19% or 13% and all that basis. So this is what like the categorical, and based on probabilities we can calculate. So for probability, you can simply try the methods how to go with the probability. Just take a look. So use the model of coefficient and intercepted values and return the new value. This is how it works. So what is the probability and the coefficient? And then on the basis of probabilities of the coefficient value and their interception value, it generates a new value observations based on that. So one method, you can simply create a method called log it to probe, and that is log r comma x. And under this, you try to correlate log r dot coefficient multiply by x dot log dot intercept. So coefficient, you know how to find the coefficient of log r, this model. From this model, you are identifying the coefficient value, and in the same way, from the same model, we are trying to identify the interception value. And do you find, so coefficient multiplied by total x, right, particular value of that x. So you, this is your coefficient multiplied by that particular value of the x, because it's a method, it is a method, and with the plus of that interception value. So you will get again one numerical odds, go for the exponential value of that odds, and that odds upon 1 plus odds. This is the method for the probability, and you will return the value of that probability, right? It is explained, and simply you need to run the same thing as you fit your data, right? After fitting your data, just you need to call this method and simply print your probe method. So pass your model, and then the value of x, each x, that is the array. For each array, what is the level of probability for each value, you will find this result. Got it? So using logistic regression, how you can go for prediction, find the coefficient, intercept values, and on that basis go for a on basis of probability, राइट अच्छा एक और चीज याद रखिए लॉजिस्टिक रिग्रेशन में प्रोबेबिलिटी पे चलता है प्रेडिक्शंस पे नहीं चलता है ना सो इट्स अ प्रोबेबिलिटी वी यूज द वर्ड जनरली प्रोबेबिलिटी नॉट डायरेक्टली प्रेडिक्शंस ठीक है एंड जनरली द अदर रिग्रेशन आर बेस्ड ऑन प्रेडिक्शंस ठीक है ना तो वहां हम प्रेडिक्ट तो कर रहे हैं यहाँ प्रोबेबिलिटी के बेसिस पे प्रेडिक्शंस हो रहे हैं so that's a major difference. You will find that is a probability based model, and for that we use a logistic regression. Hope things are now clear to all of you. So please go through with these sessions. I have explained you all these sessions, and I think in the same way you can start working. Various other algorithms are there, so you need to complete all these algorithms. I think the content is already there with the, that's why I'm using very common examples and public examples so that you can find these examples easily, right? With the code and with explanations. So that's why I'm taking this. Otherwise, you have various other choice. Yesterday, I have shown you all the choice by using Geek for Geek, Kaggle, Tutorial Point is also one of the site which you can try, right? Any doubt, any query? So I think it's good to go. You can practice all these methods and complete your sessions of machine learning, AI and machine learning. Complete your all the sessions. Still, you are working with the supervised learning model because our data is a labeled data, and as it is a labeled data, that is why you can able to able to perform on it. Okay, so just remember that this is a labeled data. Okay, and on labeled data we are using this algorithm. Further, we can try for unlabeled data, that is unstructured or unlabeled data, and then we'll try to find out that part. Already in the reference some Geek for Geek and you can say analytics with there, but I think Geek for Geek is far better. You can try this for more learning, for more advanced results with explanations. Okay, so just try it, and in case you face any inconvenience, so let me know. So please do the practicals and complete your practicals as soon as possible. So fine, take your time, just complete this part, and I think afterwards we'll start next session also, and we'll go for some more algorithms. Somewhere we'll start, I think by 1 1:30 around. I think you will get a good time for, if you want to go for a lunch you can go for. Today we have another session na, 1 to 4. So same way I think you can try. Yeah, for today it's 23rd. Yeah, AI labs and all. So AI or machine learning, I think we are doing in the mixed form. So that's good to go. I think just complete this part, and still if you face any inconvenience, so let me know. Right? So please practice. Meanwhile, I'll take your attendance also. So I think now you can go for a practice. Complete your all these algorithms. And in case you face any inconvenience, so let me know.
Good afternoon, sir.
Practicals Orange. Any doubt in any practical? So let's start with another algorithm. In this case, we don't have SVM. Okay, no problem. So let us try with the another algorithm called SVM in Python. So you can try, I think Geek for Geek is a good one for SVM. You must try Geek for Geek. So that is the way how you can have another algorithm for the classification of your data using SVM, right? So what is SVM? What is the content? Everything has mentioned very clearly in your Geek for Geek. So let's start with this. So whenever we are going to support like classification, so I think we did a lot of classification algorithms, and let's compare with other things. In fact, your with various other algorithms. If you really compare with SVM, that is a wonderful algorithm and give more advanced results and accurate results as compared to the others. So if you compare which algorithm is better on which particular database, so you keep a common database. It's better to keep your database as a common database. Okay, and on a common database, the best practice is you should keep the same database and apply multiple algorithms for classifications. So once you classify, compare with these 4 5 different algorithms and then see the result and their level of accuracy or predictions and all. So you will find best results out of it. Right. So what is SVM now? Supervised learning algorithm. That is again under the supervised because we are in classification. If it is unsupervised, then it is not called classification. It is generally called as, then basically it's called as clustering. So we are trying to create a different clusters instead of classifying, right? So there you have options of supervised learning of classifications and regression tasks. They are handled both a linear and non-linear data set by identifying the optimal decision boundaries like hyperplane. So there you will find a hyperplane model that separates your class with the maximum margins. Okay, so this is how you are supposed to find the margins and all other stuff. So in this way, you can find what is this SVM altogether. And then further, let's try to identify and optimize the boundaries, that is using hyperplane model. So what is hyperplane? It is again, it could be in 2D or 3D plane, right? With a higher dimensions model. Support vectors. So that is a data point closest to the hyperplane. In the same pattern as we did earlier for the regression, same. We are now there. You need a polynomial, regressions and all. Same way we are now. This time we are using a hyperplane model, and we are trying to identify the support vectors are basically the data points which are the closest to the hyperplane. Okay, so these points directly influence its positioning and their orientation. So both the things being covered in this case, it's a position along with their orientation. The margin, that is the distance between the hyperplane and the nearest support vector from each class. So according to the class, we also divide the things into the form of classes for the purpose of classifications. And under that, what the number of margins which are very near to it, right? Which are really very near to it, and accordingly your SVM would perform and aim to maximize the margin for the better robustness and generalization. That means the more nearest the distance between the hyperplane and the nearest support for each class. The more near means the more margin. Maximize the margin for better robustness and generalization. Regularization parameters. Now, what is the regularization? That is control the trade-off between the maximized margining and minimized classification errors. So we have to maximize the margin, but we have to minimize the errors, right? Classified errors. So a high value of C priority, C, what is C? C parameter. So high value of the C priority, correct classifications, but may overfit. Means if you, now again the problem is if you your go to the higher priority, higher value of C prioritization, then it could be overfit, underfit, or overfit. So there are two different ways, right? If the errors are more, then it is underfit. Then if your C value of the classification is more, then it is overfit. So we want not overfit or even not underfit, right? So we want a proper margin to be increased so that the things is to be managed in the proper way. So the lower value of C prioritize the larger margin but may underfit. So understood what is overfit and underfit model. Okay, and now let's going to optimize this object of this SVM, which contains the optimization model. So two major goals are there: maximize the margin between the classes for the better generalization and minimize the classification errors on training data controlled by the parameter C. This is how it works, right? So what is the kernel trick? Now, in the real-time data is rarely linearly separatable. That the kernel trick elegantly solved this by implementing the mapping data into the higher dimension space, where the linear separation become possible without explicitly computer to be get transformed. So basically, Linux kernel. So kernel operations need to be understand that how it is to be performed. So we are supposed to map the data to the higher dimension space, okay, where the linear separation becomes possible without expliciting the computing of that transformation of that data. So you have various other computation kernel, that is linear kernel, same way in the polynomial kernel. So radius based function of RBF kernel and sigmoid kernel. Generally in SVM, you might see that either will go with the sigmoid kernel or sometimes with the linear kernel. So depend upon like which type of kernel you want to process, so that your data is to be managed on in that generalized forms. So uh, how to identify segment? There are even mathematical functions and there are certain characteristics. So graphical characters are there, like for RBF you find this kind of characters, degree of D in polynomial, baselines which we need to identify from the kernel, linear kernel, or sigmoid, right, which reassemble the neural network activation functions whenever we want more efficient data, right? So but is less common in practice due to the limited efficient effectiveness. So there are various different methods which we can try for different purpose, different tasks. Some libraries, Python libraries, NumPy, Matplotlib, load breast cancer, the data set, as earlier we also worked on it. And same way, scalar, standard scalar feature. So we use that and SVM algorithm from scikit-learn library. So NumPy, Matplot, everything is in the same format. Okay, we need to log in once you will find. So just try to import all these libraries, load your data set. Once you load your data set, again you define your data in X and Y parameters. So for uh, that is independent variables and then dependent variables. Split your data, because we are into the machine learning, train test split methods are required. You need to apply train test split method with 80-20 ratio for the random state of 42, right? That is for reproducibility of the data, ensures the reproducibility. So there is a random state number, that is 42. So randomly, we can pick the data with 80-20 ratio and split that data randomly into X trained, X test, and Y trained and Y test data set. Once it is being done, use your method, scalar method, for standardization by removing mean and scaling the unit of your variance, right? And fit your data. Finally, you have to fit and transform your data. So let's say first we'll use a scalar method. From a scalar method, try to fit and transform your data of X trained data set. Okay, you got an X trained scalar value and scale the value of X test. So we got trained and tested data set, both 100% of X coordinate data set into two different objects, basically collections. And these objects are basically support your model, which got data to be get fitted into this particular part, and along with that we transform that data as well. Accordingly, we need to apply the the SVM classifier. So apply the SVM, which algorithm you are applying, say linear kernel classification, C value, let's say keep it 1 for the regularization to the parameters and control and margin versus misclassification. I think we already discussed what is C, and fit the method. So that's it. You use simple SVM, define your kernel, value of C, random state, make an object of SVM classifier, and simply fit your data of the trained scale data with the Y trained data set, right? So this is the scaled data and this is unscaled data. Understood? Because whenever you are going to place your data, you should be transform and scale that data into your memory. So in X, data was already scaled data, so we place that scaled data, and now we got a open-ended data that is from Y, which is unscaled data, and we have to correlate and compare the things. So we have a X trained scaled and Y trained data which is being fitted to the SVM. Now further we'll go for predict, accuracy score, and classification reports. So simply SVM classifier dot predict X test scaled values. So you got a Y predict data, and on this Y predict you can find the accuracy score method where you pass a Y test and Y predict one by one with the percentage of two decimals and all, and then classification reports. So you will find a proper classification record that what is a positive value and their confidence, negative value and confidence. This is a fantastic movie, boring and terrible film. So we have a separations of these kind of things. Great story and acting if you want to predict, and then you got some results. So this way you can go for it, and you can implement what is SVM, right? Supervised vector model SVM, where you try to implement, find your data set and identify how to train your data set, train your engine of machine learning engine. And once it's being trained, then we can identify the results or compare the results and find accuracy and other analytical results to be get generated through that. Is that clear? And further for visualization of your decision boundaries and all, something like this you want. So again, you got a result, define your plot, pass your XY model and scalar positioning, step size for mesh, and Xmin, Xmax, define your Xmin, Xmax, Ymin, Ymax, and then we have a np.mesh grid, and arrange your data set within that np.mesh grid. And based on that, you got a prediction value. If you got a new value, so go with Z and then plot it on scatter. The moment you plot, you will find those points like which are very near to it and which are belongs to which particular category. This way you will find more data set, right? So the purpose details, so support vector machine SVM part is there, and I think you can run this algorithm, right? So try to work on SVM also, which is good and very important part. So you can select your own data set and choose your own data set for SVM and try to implement like this. So I think this is what we are through with this. And at the same time, you want a support vector regression. So you can try a support vector regression also. So this is SVR. One is SVM and this is SVR. You will get the code or you can execute the things as well using SVR. I think almost similar kind of code, but yes, the results are varying. So you can just check. They're also using the linear kernel model, but your data comes into the sine curve data. So how to fit your SVR model on the sine curve data and generate the linear using linear kernel model. This is how it works. And then you have a polynomial kernel. So you got polynomial kernel, and accordingly you can prepare your data set. Rest all the basic things are same, whatever we did earlier. So rest all the things are same if you will check, but you have a regression means part. So type of it's also a part of SVM, and that is used for the regression tasks. So try to find the functions for the best practice and continue output with given input value. Again, use a linear and non-linear data set. Simply dot to be get a simple dot product between two input vectors. And while non-linear kernel, it is more complex function that can be captured more uh, intricate pattern in the data. So the choice of kernel depends on the data's characteristics and the task complexities based on SVR. So R is again regression with the support vectors. It's just like that. Same things which we have already discussed, and then you have a content. Import your libraries, sort your data, and place it onto the sign graph. Right, try to give your data into onto the sign graph, so that signal, this dot points would be there, and then your x and y data. Add noise to the data, like how random values you are supposed to add, because we are not taking a default data set. Okay, so we are trying to generate a data set, and we are trying to add a noise with some data set randomly, and use this kernel, fit your value, then simply predict on X, you got Y predictions, and place that on the scatter plot, and label which is to be prediction, go with legends, and show the result. So you will get a proper result, right? And in the same way, if you want to go with the other one, instead of taking that linear, now you will take a polynomial kernel, right? So if you take polynomial, so your data is again already into the sine curve, but your data finally comes into the polynomial part, and it gives you the another way of impact, like how SVM will support. So it's just a part of SVM, that is SVR. So I think just implement these practicals. It would be really good to go. Any doubt? So please start working on this, and still you face any inconvenience, so let me know. So there we have a concepts of SVR. Just implement it.